So we're going to take a look at quadratic formula. Okay, and the first thing I'm going to do is I'm going to write down the quadratic formula over here. So we have x is equal to, actually I lied, I'm not going to do that first. We're going to define what form this quadratic is in. This is currently in standard form, okay, which is an important piece. You need to be in standard form to use the quadratic formula because we know we have other forms like factored and vertex. We got to be in standard. And we're going to write the general equation of it, which is that version that has an A, B, and a C to it. So we have A, we have B, and we have C. And the reason I put those there is when we look at the standard form, we have to be able to identify which is the coefficient A, which is the coefficient B, and what is the constant C. So 18 is our C, positive 20 is our B, and negative 5 is our A. The quadratic formula, what it does is it finds the x value when y is equal to 0, okay? And it's a formula that says x is equal to, and then we're going to write the entire equation out here. And x is actually equal to negative, and then we have the letter b. So I'm going to try to color code them, okay? Now, plus or minus. I'm going to talk about that concept, plus or minus. It's because you can potentially get two different answers.
Because of the square root.
Yeah, exactly. We have a square root, and then in the square root, you have b squared. Okay, I'm going to need more room here. And then we subtract the number 4 times the coefficient a times the constant c. And then all of that is above the letter 2 multiplied by a. So this here is a formula in itself. Okay, so I'm going to put a box around it. This formula specifically pertains to the general equation of the standard form. So we got to find out what our A, B, and C value are because we have to plug in B's, 2 A's, and a C. And then we work this thing out. Okay? We'll talk about what it works out and then how we can actually use it to build another form. Okay? So first off, we're going to put this through. We're going to find y is equal to 0 by using this quadratic formula. So I'm going to build it here. We have x is equal to negative, well, what's my b value? My b value is 20. So negative 20 plus or minus the square root. Make it a little bigger. Okay. And the square root says b, which in our case is 20 squared, minus 4 times our a value is negative 5, so 4 times negative 5, times our c value is 18. And all of that will be divided by 2 times our a value, which is also negative 5. So there's some trickier math to this. There's quite a bit we have to work out underneath the square root. We can simplify our denominator. And then we have two terms here where we're actually going to have to split this. There's a rare occasion where they end up being the same answer. That is possible. But let's take a look at what we have here. X is equal to, we're going to start to simplify. This is all going to be over, so it's a fraction. Negative times 20, or in other words, negative 20, plus or minus. And let's square root this, or let's simplify the square root. 20 squared is 400. Oh, those aren't the same as I want it. So 20 squared is 400. Negative 4 times negative 5. That's actually going to give me positive 20. So I'm going to do a little side calculation. Negative 4 times negative 5 gives me positive 20. And then I have to take that 20 and multiply by that C value, 18.
I believe that's 320.
Yeah, that's it. 360, I think. Yeah, it should be 360. So that's going to be positive 360. And then below we have negative 10. Carry out one more step. X is equal to negative 20 plus or minus the square root of 760. And all of that will be divided by negative 10. Okay, I can figure out the square root and give me some value. I'm just going to leave it at that at the moment. What I'm going to do from here is I'm going to split. Because when we square root something, you get both a positive and a negative answer. We got x is equal to negative 20 plus the square root of 760 divided by negative 10. And you get x is equal to negative 20 minus the square root of 760 divided by negative 10. So we have two answers. This might look familiar to the process of factoring. When we factor, we usually end up with two values. When we have this scenario, we have something like this. It'll be like x minus 5, x plus 2 is equal to 0. We usually go x minus 5 equals 0, and x plus 2 equals 0. We've split the equation here. That's precisely what we're doing, and that kind of hints at what we're trying to find. Factoring helps us find x-intercepts. That's what a quadratic formula helps us find, okay? It just helps us find it when it's more difficult or something we can't factor, like this specific example. What can I do for roots here? I could run a calculator through it. Let's see if we can find the square root. You want to quickly do square root of 760?
Yep, hang on a second. 27.56.
Okay, 27.56 approximately, okay? X is negative 20 minus. Now you could be more exact by working with radicals, but you guys haven't really done that yet, so we're going to just shy away from it.
She's also trying to make us use radicals as well.
Does she? Okay, well, we can reduce the radical. When you reduce a radical, okay, let's find this, and then we'll talk about reducing the
But when
radical.
calculating all the roots,
Yeah, you got to find all the factors of it and all the ones that are perfect squares to help us reduce it. Okay, in this scenario here, 20 minus this value will actually give us this 7.56. Divide negative 10. What's great about dividing 10, we just move a decimal and I make this negative 0.756. So approximately, there's one of the roots. This one here, we get x is equal to negative 47.56. Divide negative 10. That gives us a positive, and it'll be positive 4.576. So approximately. So what we've just discovered, approximations, are the two roots. Okay, so if I were to do a little graph here, one of the roots is at negative 0.7, so about negative 1. We could argue it's there. And the other root's at 4.7, maybe around 5-ish, okay? And this was an equation that had negative 5 as the a value, so that means it goes up and comes down, does something like that. How does this help us change forms? Well, we just found two roots. We can recreate the factored form from here. If you remember the general equation for the factored form, it is y is equal to a x minus, what letters do you use? R and S?
S and T.
S and T, okay. S and T. Those S and T's, those are the roots. So we can just assign that this is the value of S, this is the value of T. We can now recreate factored form from this, which isn't a common thing to do, but we can easily do it. The a value, if you remember from the beginning, is negative 5. I'm just going to go back up and show you that. That a value is 5. And so what's unique about all these different forms is the a value is always the same. We have negative 5. And then x subtract s value is negative 0.756. And the t value, we have x minus 4.756. We do a little simplifying. Y is equal to negative 5, x plus 0.756 times x minus 4.756. Now these are approximations, but this is a pretty good approximation. Let's zoom out a little. So what we've just done, look at a quick overview of it all. Can I fit it all in? No, it's pretty big here. Okay. We started with our standard form, and we knew we had to use quadratic formula. Quadratic formula solves for when y is 0. In other words, it helps us solve the roots. We got to do all the calculating, which is a bit of the hard part. But once we get to our final answers, we have the two roots. If we have two roots, we can build factored form. We have already the a value, and we can plug the roots in for s and t. I now have factored form. Imagine trying to factor using these values. This thing here. Almost impossible. You would have never got it. It would have been too hard in terms of mental math to do. So we can use quadratic formula to also factor things. Let's talk about one last piece, radicals. How could we have technically used a radical here? I'm going to show you a quick idea. Root 760. Okay. 760 can be broken into a bunch of factors. Okay. So in other words, I can break this into root 10 times 76. I quickly knew that 10 times 76 gives me 760. So I can break it into two radicals. Okay. 76 factors of 76. 2. If I add them up, 13. 2 goes into it. Let's see how many times 2 goes in. Root 2. 2 goes in 1, 2, 3, 38. Yeah, that makes sense. 10 I can break into root 2 and root 5. So what I've just done is broken in factors. You ever do prime factors? It's the same idea of building prime factors. We can break these all up, okay? 38 can be broken up. You can go into root 2. 2 times 1, 8, 19. There we go. We finally get a prime number there. And we got root 2, and root 5. What I've just done is I've broken this into all of the prime factors of 760. Now the question becomes, are any of these the same? Yeah, this one here is the same. Okay? In other words, what's root 2 times root 2? Well, root 2 times root 2 is just the number 2. Any pairings I get, I can build and use those. Now this is the only pairing. The rest of these are all separate. So what I do have now, as a way of breaking it up, I have the number 2. It's no longer a root. Root 2 times root 5 times root 2 times root 19. Well, because none of these are the same, it's actually easier to put these all back together. Bit of a longer process. I could have just looked for perfect squares, but this one is like a definitive way to do it. If I put those all together, I think I end up with whatever 4 divided by that is. This should be 10. Root 190 looks like. Okay, so if we were to have left this as a radical answer, this, instead of putting like negative 27.56 or positive 27.56, we could have left this as 2 times root 190. Okay, indifferent either way, just kind of a preference of what your teacher probably has. Okay.